name's Tim Panton, and this is a reconstruction of my hack at TADHack in Paris involving remote monitoring of a WebRTC enabled IoT device, both through mobile phone and through Cisco Spark. So let me take you through what you can see on the screen. Well, obviously you can see me, hello, up in the left side, and that's in an appear in window, which I've used to do a WebRTC call to another camera which is pointing at this IoT device here. So the IoT device consists of a BeagleBone Black, which is a small ARM Linux machine, which is connected to some sensors and to a serial display so that you can see some values. Right, and so the idea of this hack is to be able to remotely monitor the value of the sensor, but initially from my mobile phone. So what we'll do then to do that is we'll run on the BeagleBone, we'll run, in fact in Java, an implementation that I've written of the WebRTC data channel. So that's now running on the BeagleBone. And now on the right hand side, what you see here is a reflection, which Chrome does this really nice thing, of reflects a web page that's viewed, that's actually on my mobile phone here, reflects it up into the browser so that you and I can see it in this video. So now, if we load this page, then what I can do is I can press connect, and that now connects to the BeagleBone, starts a WebRTC data channel, and we'll, once it's got that set up, we'll start reading the value and relaying it to this sensor here. And what's nice is that sensor is actually keeping track very closely with the values on the device. And if you can see that if I cover this up, we'll get a much lower reading. And then I can take my finger off it and we'll come back up again. So that's a very nice remote monitor for this device. And I would point out that this data is not going through a web server. Now, the initial setup was obviously from a web server, but the actual data is going point-to-point encrypted using WebRTC. And that brings out the other thing, which is how do you protect this against other people being able to access it when you don't want them to? So the way this does it is both ends know about the public key of the other end, and they protect themselves like that. So to demonstrate that, what I'm going to do is to remove the public key, my phone's public key, which is currently installed in the BeagleBone device. So if I remove that from the key store, I will demonstrate a very easy method we have for adding public keys to the key store. So it goes like this. So you start the BeagleBone app again, and when it starts up, it notices it doesn't have a public key for its master. And that will cause it to go looking for a master. So anyone who is physically in proximity and therefore presumably in control of the device is now able to go to the device and scan that QR code . I have a slightly wobbly hand today. Too much drinking. There we go. And they they exchange the certificates, and now we can start a connection. And what you'll see is that once that connection started and the certificate's been accepted, the QR code vanishes, and we're back to the situation of having a remote monitoring. And anytime I restart this app, I will not have to go through that process again because the certificates are stored locally. So now we have a secure method of connecting to a device without using passwords. No passwords were used, no typing, because there's no keyboard on this thing. So that's that, but that's not really enough for managers. I mean, this is somebody who is actively involved in this day in, day out will browse to this web page and get the data. But if you're a manager, that's probably insufficient. Most managers actually spend their lives these days, I find, in instant messengers. So I did a version of this code for the Spark IM using the new SDK that they've released from Cisco Spark. So the way that that works is quite similar. Basically on the BeagleBone we run an app, actually a different app in this case. We run an app which monitors the voltage, and nothing happens, which is kind of what you would want if you're a manager, until, let's say, the voltage drops, at which point I should receive an alert. And it may take a little while because it has to work its way through the out into the cloud infrastructure and add some capabilities, and there we go. So we now have emergency notification that the voltage has dropped, and what you see now is that that voltage is relayed to me if it's below a certain threshold, and when it rises above that threshold it stops relaying it. Now I can then add somebody to this chat, ask them to help fix it, and then when we're done we do the normal process of deleting that chat and say we're good, and then when it goes wrong again you'll get another chat. So what I've shown you today is secure connection between a WebRTC device, WebRTC IoT device, and a mobile phone, and then a connection between the same IoT device and Cisco Spark using their new APIs. So that's the story, and I think this is important stuff.